Welcome everyone. So today we're going to discuss about the homogeneity of time and the conservation of energy. So closed system exhibit symmetry with respect to time translation. What it means actually, the time homogeneity is the consequence of the fact that the Lagrangian of the system has no explicit time dependence. That means del L by del T is equals to 0. So there will be no time part on the Lagrangian. That means the Lagrangian will be the function of q and q dot, generalized coordinate and velocity only. Okay, now the total time derivative of the Lagrangian in such a case is given by dl by dt is equals to summation I del L by del qi dot qi double dot plus summation I del L del qi into qi dot equals to this term. So we can write it or simplify it in this way, that summation I ddt of del L del qi dot into qi dot. So we define the Hamiltonian of the system as h equals to summation I del L by del qi dot into qi dot minus L. Here L is the Lagrangian. So dh by dt is equals to 0. Let us consider a closed system for which the kinetic energy is expressible as a bilinear product of generalized velocities and the potential energy is a function of the generalized coordinates alone. So the kinetic energy T is the bilinear product of generalized velocities. That means T is equals to half summation I j Cij qi dot qj dot. Here qi qj dot and Cij is equals to Cji could be functions of generalized coordinates but not of velocities or of time. So the Lagrangian L is equals to t minus v, where t is the function of generalized velocities qi dot and v is the potential energy which is the function of generalized coordinate qij. Okay, so now from the definition of the Lagrangian L, we get del L by del qk dot into qk dot is this term. Now doing the derivatives and applying the values of kinetic energy T from our previous calculation, we get that this term is equals to 2T. Now using the definition of the Hamiltonian, H is equals to summation I del L del qi dot into qi dot minus L, which is equals to 2T minus L, because this term from this calculation we can see is 2t. So putting the value of 2t in place of this term, we get 2t minus L, and as we know that L is equals to t minus v, so we get 2t minus t minus v, which is t plus v. So here T plus V is the total energy of the system. So in case of homogeneity of time, the total energy of the system is conserved. So this was our discussion on the conservation of energy and homogeneity of time, and on our next class we're going to discuss about some other topic. Thank you everyone.